Hello students, I am Sasitakar. Welcome to Cars Physics. This is my lecture 2 on electric charge and electric field, which comes under the units electrostatics. In lecture 1 we have discussed about different properties of charge, and in this lecture we will discuss about electrification or charging. Okay. So what is electrification? Electrification, it's a process or it's a method. It's a process of converting a neutral body, neutral, or you may write an uncharged body, uncharged or neutral, uncharged body to a charged body. Okay. It is the method of conversion of uncharged body or neutral body to a charged body. Okay. Then about matter, what we have discussed. Matter composed of atoms, and atom is electrically neutral. Okay. So a body or a matter is usually neutral. A body is said to be charged, or a body is said to be electrified if the body either loses electron or gains electron. If a body loses electron due to deficiency of electron, net charge on the body becomes positive, so the body is said to be positively charged. And similar, if a body gains electron due to excess of electron, net charge of the body becomes negative and the body is said to be negatively charged. So overall we may say, if a body loses electron, the body becomes positively charged, and if a body gains electron, it becomes negatively charged. So electrification is due to loss or gain of electrons by a body. So electrification is due to either loss or gain of electrons. As we have discussed, if a body loses electron, it becomes positively charged, and if a body gains electron, then it becomes negatively charged. So this is about definition of electrification. Okay. Next, different methods of electrification. Okay. There are three methods of electrification. Number one, friction. Number two, conduction. And number three, induction. Okay. Friction or frictional electrification. Okay. We will use the method of electrification to charge a body, to charge a neutral body or to charge an uncharged body. Okay. The method electrification frictional method of electrification is used to charge only insulators. Okay. Frictional electrification is used to charge an insulating body or to charge insulators. But both the methods conduction and induction are used to charge conductors. Okay. We will discuss in brief. Then, before going to the methods, friction, conduction and induction, let's have an idea. Suppose I am discussing about a conductor. Okay. Conductor. In usual form, we define the conductor as a conductor is a substance which allows the flow of charge in it, or we may say a conductor contains a high number density of free electrons. So what are the free electrons? Okay. Every matter composed of atoms. Okay. Atom contains nucleus, which is positively charged. As we have discussed, nucleus contains neutrons and protons. Neutron is electrically neutral. Only charge of nucleus is due to protons, which are positively charged. So around which means around nucleus electrons revolve in different orbits. Okay, the electron which orbits around nucleus in outermost orbit means the electron which revolves around nucleus in outermost orbit may be called as valence electron. Okay, at ordinary state, suppose I am discussing in brief, at 0 Kelvin, when temperature is 0 Kelvin or minus 273 degrees centigrade. Of course, to attain 0 Kelvin is not possible. Okay, if we consider, suppose a body, conducting body or insulating body is at 0 Kelvin or at minus 273 degree Celsius. Okay, at 0 Kelvin, the electron has or the electrons have negligible amount of energy. Okay, it doesn't mean that the electrons stop their motion. This is a misconception. Usually, we do mean that when temperature becomes 0 Kelvin or minus 273 degrees Celsius, then electrons become motionless. But this is conceptually wrong. Okay. According to analysis or experiment, even at 0 Kelvin means temperature doesn't affect the electrostatic force of attraction between nucleus, positively charged nucleus and negatively charged electron. Okay. So even at 0 Kelvin, electrons whiz around the nucleus. Okay. Then at 0 Kelvin, electrons will come to our usual discussion. At 0 Kelvin, the electrons do not possess sufficient amount of energy so as to escape out from the orbit of nucleus. Okay. Suppose temperature is increased and reaches our normal temperature or at room temperature. We do consider our room temperature is 27 degrees centigrade. Okay. In Kelvin, it will become 300 Kelvin. So temperature rises from 0 Kelvin to 300 Kelvin. Okay. So when temperature increases, even if at room temperature, normal room temperature, electrons acquire sufficient amount of energy, means thermal energy due to increase in temperature. Okay. And this energy helps the electrons out from the nucleus, means gaining such energy. These electrons which are in outermost orbit may escape from the orbit because the electrons in outermost orbit are sufficiently apparatus, means relatively apparatus as compared to the other electrons in inner orbits because it is in outermost orbit. So this electron can easily escape from the orbit by gaining thermal energy. When the electron is set free, from the orbit, it becomes free. Okay, and additional energy means the thermal energy present in the body helps the electron to move in random motion throughout the conductor. These electrons, once set free, are called as free electrons. Okay, thus we say conductors are the substances which allow the flow of charge, or conductors contain high number density of free electrons. The approximate number density of free electrons is about, approximately equals to 10 to the power 28 number of free electrons per unit volume of 1 meter cube. See students, this number means power of 1028 may vary depending upon the nature of material of the conductor. This is an elemental idea about conductor and about insulators. We do say insulators do not contain free electrons at any temperature, but this is not conceptually right. Even we do say insulators have no free electrons, but practically insulators may contain a very low number density of free electrons. which are maybe considered to be negligible. Okay, so usually we say, not saying negligible, insulators do not contain free electrons, or insulators do not allow the flow of charge in them. Okay, this is about conductor and insulator. Then another term comes in my mind, we should discuss in very short form. That name is semiconductor. You will study about semiconductors in brief. Okay, this is very useful subject for you. And in our modern days, semiconductor devices, junction diode, transistors have wide range of use in overall in almost all electronics instruments. Okay, so this subject, semiconductor electronics is very important for us. Okay, then what is semiconductor? Circle, circle and semicircle. Semicircle means a half circle. Conductor, what we have discussed about conductor. Semiconductor of half the conductor. Oh no, I mean to say that characteristics of semiconductor lies between conductor and insulator. Okay, we will study in brief. When you will study semiconductor electronics, you will study the classification of solids, means conductor, insulator and semiconductor, on the basis of band gap theory, or valence band, conduction band, the energy gap, band gap. Okay, we will study in brief. Just only we should have an elemental idea. Okay. So conductor, semiconductor and insulator, but finally I may say all these terms, conductor, insulator and semiconductor, are only relative terms. No one is perfectly conducting or no one is perfectly insulating. For example, we may say till date, means now, we may say silver is best conductor. Okay. But we use copper in our household wiring, etc. Because cost of silver is too high, though it is a better conductor than copper. Relatively, silver is better conductor than copper. Copper is better conductor as compared to aluminium. We don't use aluminium because conductivity of aluminium is less as compared to copper. Conductivity, the term conductivity, more the conductivity, better is the conductor. Okay, less the resistivity, better is the conductor. So for a good conductor, conductivity is high and resistivity is low. Okay, then conductivity of a silver is more as compared to copper. So we use copper in our usual household wiring. Okay. For insulators, conductivity is low and resistivity is high. Okay. Then overall we may say the electrons move in conductor due to thermal agitation or due to thermal energy or due to temperature effect. So effect of temperature plays a great role for conductivity and resistivity. We will study about conductivity and resistivity in brief in current electricity. Okay. And we may say if temperature of conductor increases, then its conductivity decreases or resistivity increases. Okay. For a semiconductor, if temperature increases, conductivity increases and resistivity decreases. At 0 Kelvin, semiconductor behaves as insulator. Okay. With rise in temperature, even at ordinary room temperature, semiconductor behaves as conductor. Okay. Then another term is there, that is superconductor, which is yet to be found at our normal temperature. Superconductor is found, but not in our normal temperature. For example, mercury shows superconductivity below 4.2 Kelvin and lead shows superconductivity below 7.2 Kelvin. The two low temperature, 7.2 Kelvin, 4.2 Kelvin. Okay. Superconductor. Superconductor has zero resistivity. Resistivity zero. So conductivity is too high. Means if resistivity is zero and current will flow through superconductor, no amount of energy will be lost in the form of heat. As we see, if current flows through aluminum wire or copper wire or silver wire, then the substances get hot due to loss of energy. In superconductor, there will be no loss of energy due to resistivity. These are formal discussion. You should keep in mind. Thus, only elemental discussion on conductor, semiconductor, and insulators. Then we will return to our usual studies. First method of electrification is friction. Frictional electrification, we have already discussed about it. If two different bodies, looking different, I mean to say, if nature of materials are different of the bodies, if two different bodies are rubbed against each other, in 600 BC, okay, Thales found that if umber is rubbed against woolen cloth, then the umber acquires the property to attract lighter objects. So this is frictional electrification. So what is mechanism behind frictional electrification? If two different bodies are rubbed against each other, due to friction on the surfaces, energy is lost. You know it? Energy is lost. And the loss of energy appears in the form of heat, or loss of energy is converted to thermal energy. Okay. That thermal energy helps in transferring the electrons from one body to another body at the point of contact. If two bodies are in contact and rubbed against each other, then the thermal energy helps in transferring the electrons from one body to another body. Thus we get a point. Frictional electrification takes place due to transfer of charge. Frictional electrification takes place due to transfer of charge. Okay. If two bodies are rubbed against each other, electrons are transferred from one body to another body. So due to transfer of charge. Okay. The body which gains electrons. The body which gains electrons due to excess of electrons, net charge will be negative. The body becomes negatively charged. Okay. What will be the charge? Let minus q. Let the body gains n number of electrons. Total negative charge is minus n. Okay. Again, suppose this is a body A, this is body B, this is another body B, rubbed against each other. Rubbed against each other. This is body B. Okay. The body which losses electron. Body which losses electron due to deficiency of electron. Net charge on the body which losses electrons will be positive because net charge is positive. The body will be positively charged, and that positive charge, let plus q, again it will be plus ne because electrons lost by the body, number of electrons lost by body A is n, and number of electrons gained by body B is also n. So this body will have plus q and this body will have minus q. So during frictional electrification, the bodies rubbed against each other, okay, acquire equal amount of charge, means magnitude of charges is same but opposite in nature. One is positive and other is negative. Another thing, electrons are transferred from body A to body B. Body A becomes positively charged, means electrons are transferred. As we have discussed, charge is always associated with mass. If electrons are transferred from body A to body B, then masses are also transferred from body A to body B. So, body A becomes positively charged and it loses mass. Mass of the body, positively charged body, decreases, and obviously mass of the negatively charged body increases, means negatively charged body gains mass. Okay, this is about frictional electrification. You may take screenshot. Okay, 1, 2, 3, 4. Okay, then some questions related to frictional electrification. Let's discuss some one or two questions. The vehicles carrying inflammable substances, or you may say gasoline tankers, or the vehicles carrying petroleum products. Okay, the vehicles carrying inflammable substances carry a metallic chain suspended from vehicle touching to earth. Why? See students, charges move only in conductors, as we have discussed. Charges do not move in insulating medium. Air is insulator, dry air is insulator. Charges can't move in dry air. Charges always seek a conducting medium to move. Okay. Then why the vehicles carrying inflammable substance should carry a metallic chain? Similar question. Why the tires of aeroplane? Why the tires of aeroplane are made slightly conducting? The tires of our vehicle, two-wheeler or four-wheeler, are made up of rubber, which are perfectly insulators. But the tires of aeroplane made up of rubber, but with slightly conducting. Why? The answer is same. Because when the vehicle carrying inflammable substance or the aeroplane moves in air medium, vehicle moves on the road on air medium, and during takeoff, okay, aeroplane also moves on the wrong way. Okay, then due to friction against air, the body is metallic. Due to friction against air, also due to friction of the tire on the ground, okay, there is possibility of accumulation of charge on the vehicle or on the body, means surface of aeroplane. Okay, and as you know, when charge, if you rub two bodies vigorously, then charge will transfer from one body to another body. Then during the transfer of charge, sometimes we have observed sparks. Okay, due to high accumulation of charge, due to friction against air or friction on the surface, means between tire of the vehicle and ground, there may be accumulation of charge which may produce spark, and a single spark may destroy the whole vehicle. Okay, so metallic chains are suspended from the vehicle and tires of aeroplane are made slightly conducting to have in contact, to have a touch with ground. Why? Ground is good conductor, earth is good conductor, also metallic chain is good conductor. So the charge accumulated on the surface gets a metallic path, means a conducting path to escape to earth. Okay, earth is always considered to be at zero potential or neutral. We'll study about zero potential, positive potential, negative potential in next chapter, electric potential. Okay, so any body in connection to earth also becomes neutral. Okay, we'll discuss here also when we will discuss about conduction. Okay, thus metallic chain is suspended or tire of aeroplane is made slightly conducting to keep the vehicles or aeroplane neutral, means to avoid the spark. Okay, this is about frictional electrification. Okay, you should go through it seriously. These are theoretical questions. Okay. Then the next method, conduction. Number 2, conduction. Okay. Conduction. Using conduction method of electrification, we can charge the conductors. Okay. Frictional method of electrification can't be used to charge a conductor. Why? Because you see, suppose this is a conducting body and this is an insulated body. Suppose this conducting body is rubbed on insulating body. Okay, the conductor will be charged. Okay, but the charge conductor means the charge acquired by the conductor will flow through my body to ground, because human body is good conductor. Okay, so overall we may say, if conductors gain extra electron or charge, then the charge will escape out, because conductor allows flow of charge in it. So conductors can't be charged by frictional electrification. Or you may say, if the charge, even if charge develops on a conducting body, the charge will escape out if it gets a conducting path to reach on earth. Okay. Then about conduction. Conduction is the method of electrification due to physical contact of a charged body with an uncharged body. The method of conduction implies conduction is the process of electrification due to physical contact, means the bodies must come in contact. Physical contact of a charged body with an uncharged body. Let this is uncharged body, this is a conductor. Okay, uncharged means net charge on this body is 0. Means in this body, neutral body or uncharged body, number of protons is equal to number of electrons, so that the body is neutral. 1, 2, 3, 4, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Okay, number of protons is equals to number of electrons. So sum of the charges means algebraic sum of charges of electron and proton is 0. So this conducting body is uncharged. Net charge of the body is 0. Okay. Now a body. Suppose this is an insulating body. Insulator. This insulating body is rubbed against another body, and this insulator gets charged. Means insulating body gets it converted to a charged body. I can hold it in my hand because charges will not flow in the insulator, and means it will not flow to my body. Okay. Now the charged insulating body is kept in contact with the conductor. Suppose this body is negatively charged. Okay. You may take positively charged also. Doesn't matter. Means in this body, charged body, this is charged body, and net charge is negative. Okay. This body has excess of electrons, so this body is negatively charged. Okay. If this body is brought in contact, means charged body brought in contact with uncharged conductor, then what will happen? See, just observe this electron. This electron is near the boundary of uncharged body. This electron means last electron will be repelled by all the electrons behind it. So resultant force on this electron will be maximum. So this electron will push towards pushed into the conducting body, because there is no air gap. Two bodies are in contact. If there would be air gap, then this electron would not flow to the conducting body. So the bodies are in contact, conducting body. So the electron gets an easy path to flow to the conductor. Okay. Similarly, electrons will flow from the uncharged body to the charged body. Sorry, from charged body to uncharged body. Okay. So in this way, this uncharged body gains electron. Means the uncharged body becomes negatively charged. Then what will happen? The practical mechanism. See, suppose this is the charged body, this is uncharged body, are in contact. Suppose this charged body contains 1000 number of excess electrons. Means total number of excess electrons is, let 1000. I can count 1000. Let's imagine total number of electrons are represented in this charged body is 1000 number of charge, 1000 electrons. When these bodies are brought in contact, then electrons flow to the uncharged conductor, then electrons will flow. And from here, some electrons will be decreased, number of electrons in this body will be decreased. Okay. Then how this number, means 1000 electrons, will be distributed in both charged and uncharged body? This is a question. Will the distribution of number of electrons equal? Yes. When? If the two bodies are identical in shape, then distribution of charge will be equal. How? Suppose 1000 number of electrons on this body. There will be 500 electrons and the remaining 500 electrons will be on the charged body. Why? Because due to this 500 electron, total charge is minus Q. Okay. On this body also, total charge due to 500 number of electrons, excess electron, total charge is minus Q. So this minus Q repels this minus Q. This minus Q also repels this minus Q. So these two forces will have equal in magnitude and opposite in direction. So resultant force between them will be 0. So from 1000 electrons, if the shape of the body is same, only 500 electrons can be transferred. So equal amount of charge will be developed, equal nature of charge will be developed. So finally, conduction takes place due to sharing of charge. See, charge is shared. Conduction takes place due to sharing of charge. Okay, let's have some discussion on it. Suppose two bodies are brought in contact. This is uncharged conductor. This is a charged body. You may take insulator. Total charge on this body, let you may take minus Q or you may take plus Q, whatever you. If this charge were positive, then electrons from the uncharged body will be attracted due to the positive charge. So these electrons will repelled by the other electrons, means attracted by these positive charges. Okay, these positive charges. So electrons will move from this body to this body. So due to deficiency of electron, this body will become positively charged. Okay. Also, electron is shared. All the positive charges present previously will not be neutralized. So again, net charge will be positive. So due to conduction, similar charge develops on the uncharged body. Okay. You may write it due to conduction, similar charge develops on the uncharged body. Okay. Suppose I'm erasing the diagram. Suppose these are two bodies. This is a charged body. Let charge on this body is plus Q. This is an uncharged body. Okay. After they are separated, then obviously charge will be shared. Then after conduction, both the bodies will acquire charges Q by 2, Q by 2. If this charge were negative, then this charge will be minus Q by 2, minus Q by 2. Okay. Plus minus you may take. If this is positive, both will be positive. If this is negative, both will be negative. Short words. This is a charged body. Suppose this charge is plus Q1. This is also a charged body, but conducting body. This charge is plus Q. Then after conduction takes place, charges on the bodies will be shared. Total charge on this body will be Q1 plus Q2 by 2. Also on this body is Q1 plus Q2 by 2. Okay. Then I am doing here third part. Suppose this is a charged body. Charge on this body is plus Q1. This is an uncharged body. Sorry, also a charged body. Charge on this body is minus Q2 plus Q1 minus Q2. After the method works on both the bodies, charges will be equally divided. Q1 minus Q2 by 2, Q1 minus Q2 by 2. So these will be helpful when you will attempt numericals, okay, on the basis of Coulomb's law and superposition effect. Okay. This is about conduction. Okay. Then another thing, for a charged conductor, I think you have taken your screenshot. This charge is plus or minus Q. This is neutral body. Okay. If charge is acquired by a conductor, suppose a conductor becomes negatively charged. After conduction, the total negative charge will be distributed on the surface of the conductor. This is very important to know. If charge is given to a conductor, no charge remains inside the body. Because to neutralize the mutual repulsive force, means force of repulsion between similar charges, to neutralize the force of repulsion, the charges are distributed on the surface, but the charges don't come out from the surface because outside the surface is air, which is bad conductor of electricity. Very important, you should know it. Next. The last process, induction. These theories are very conceptual. You should understand. Last process, induction. Okay. Induction is the process of electrification without physical contact of a charged body with an uncharged body. This is the charge. Let charge on this body is positive or you may take negative. Induction is the process of electrification without physical contact of a charged body with an uncharged body. Okay. This is a charged body. This is an uncharged body. What will happen? Uncharged body means number of protons is equal to number of electrons. Say number of protons is 9, so number of electrons is also 9. This is uncharged body, net charge of this body, and this is charged body, charge is positive. When a charged body is kept near an uncharged body, what will happen? If this body is positive, obviously it will attract the electrons present in this body. So those electrons, I am erasing this part. The electrons will get attracted by this positive charge and will appear at the near end. Okay. Similarly, due to excess of electron at this near end, let total charge becomes minus Q, and due to deficiency of electron at the far end, total charge is plus Q. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Okay. The middle portion remains neutral or uncharged. The opposite charges are attracted by positive, means negative charges are attracted by positive, appear at the near end due to excess of electrons at the near end. Total charge due to all these electrons is minus q. Due to deficiency of electron at far end, total charge is plus q. Okay. Then this charge is called as inducing charge. Inducing charge. These charges, both of the charges are called as induced charges. This charge is called as bound induced charge, and this charge is called as free induced charge. Okay. This is called as inducing charge body, which induces charge without physical touch. Okay. This charge is called as bound induced charge. Why? So long as the inducing charge is present, this opposite charge is bound to stay, because this charge is attracted by the opposite charge. So this charge is bound to stay. But this charge is not bound to stay. This is 3. How? If this body, I am representing in other diagram, this is plus q, this is minus q, this is plus q. Oh, fine. Okay. If this body is earthed, as we know, earth always considered to be maintained at zero potential or remain at neutral state. This end is positive. If it is connected to earth by a conducting path, then the positive charges will not flow. As you know, mass of proton is 1837 times that of mass of electron. So positive charge means protons are heavier as compared to charge of electrons. So positive charge never moves. Then what will happen? To neutralize this positive charge, electrons will flow from earth to this body, and finally this charge will vanish. So this is called as free induced charge. Okay. Then some points. I will discuss some points and I will write some points. Due to induction, 2 types of charges, positive and negative charges, are developed at the far near end or not far end. These charges are induced charges. Okay. The induced charges, 2 types of induced charges. 2 types of induced charges means positive and negative are of equal magnitude. Q and Q equal magnitude, but one is positive, other is negative. Okay. Number 2, induction is temporary process. Induction is a temporary process. Why? Because so long as the inducing charge is present, these 2 charges will maintain a distance between them. This charge is attracted by positive, and this will remain at far end due to deficiency of electron. Okay. So induction is temporary so long as the inducing charge is present. The 2 types of induced charges will get or will remain separated. Once the inducing charge is taken away, then they will again combine. So this is temporary process. Okay. Next point, very important. Number 3, induction produces attraction between charge and uncharged body. See, this body is now also uncharged because this is not earthed. Total positive is equal to total negative, net charge is 0. Induction produces attraction between charged and uncharged body. How? See students, you know gravitational force G m1 m2 by r square. So gravitational force is inversely proportional to square of distance between the masses. So this is called as inverse square law. So gravitational force obeys inverse square law. Similarly, the force between the charges means electrostatic force also obeys inverse square law. It means if distance between the charges is less, then magnitude of force will be more and vice versa. Okay, let's see. Between positive and negative charges, let distance is r1, and between similar charges, positive and positive, distance is r2. Okay, then this positive charge attracts this negative charge, let force is F1. This positive charge repels this positive charge, let force is F2. Since F1 is force of attraction between positive and negative, okay, distance is r1, means here, I will write, let's see this, okay, here R1 is less than R2, so magnitude of force F1 is greater than magnitude of force F2. Also, angle between them is 180 degree. You know it. If two vectors are oppositely directed, means angle between them is 180 degree and magnitude of one of the vector is greater than other vector, then resultant vector magnitude of resultant is difference in magnitude of the vectors. Vector has greater magnitude minus vector of smaller magnitude. So direction of resultant will be obviously along the greater one. So resultant force is directed along F1, means resultant force shows attraction between charge and uncharged body. So induction produces attraction between charge and uncharged body. Okay. Then about the induction, I have forgotten to write about the induction. Friction takes place due to transfer of charge. Conduction takes place due to sharing of charge. Induction takes place due to separation of charge. Okay, separation. Positive and negative charges are separated. Then some 1 or 2 points. Okay. See, suppose this is inducing charge on this body, let positive. Here, bound induced charge, total charge is minus q, free induced charge plus q. Now it is earthed, this charge vanished. Okay, this is inducing charge, this is induced charge. So relation between induced and inducing charge Q. If this is positive, this will be negative. If this is negative, this will be positive. So Q is equal to minus Q. Okay. If this is positive, then this will be negative. Okay. Into 1 minus 1 by epsilon r. About epsilon r, we study in next class, next lecture. Epsilon r is called as relative permittivity or dielectric constant, again the property of the insulator, which determines the insulating property. We will discuss it. Induction is also described on the basis of electrostatic polarization of dielectric medium. We will discuss it in later stage. Usually I discuss it in capacitance subject. Okay. Dielectric polarization, we will discuss it. Okay, this is called as relative permittivity or dielectric constant or specific inductive capacity. We will discuss on this in next lecture in Coulomb's law. Okay, just you remember the values of epsilon r for metals or for conductors. Value of epsilon r is infinity. Then for metals, q is equal to minus q. 1 by infinity 0. 1 minus 0 is 1, q is minus q. Means for metals, magnitude of induced charge is equal to magnitude of inducing charge, obviously opposite in nature. Okay. Magnitude same, q is equal to q. Okay. For insulators, value of epsilon r is usually greater than 1, maybe 2, 3, 4, etc. Depending upon the nature of insulators. Okay. Paper, mica, okay, porcelain, there are different types of insulators. Okay. Insulators our requirement, conductors are also a requirement. Okay. Conductor allows the flow of charges, insulator breaks the flow of charge. Okay. Both are required. Okay. For insulators, value of epsilon r is greater than 1. Say epsilon r is 2. If you take 2, 1 minus 1 by 2 is 1 by 2. Q is equal to Q by 2 means negative. Opposite nature means magnitude of Q is less than that of Q. Means magnitude of induced charge is less than that of magnitude of inducing charge. Thus overall we may say relation between induced and inducing charge irrespective of sign means nature, magnitude of induced charge may be less or may be equals to magnitude of inducing charge. So magnitude of induced charge can never be greater than the magnitude of induced charge can never be greater than magnitude of inducing charge. Okay. For vacuum, epsilon r means relative permittivity is 1. Put here 1 by 1 1 minus 1 0. So induced charge is 0. Means induction doesn't take place in vacuum because vacuum contains no particles, no masses. Where the charge will reside? Charge always comes with mass, charge always associated with mass. Thus in vacuum there is no possibility of electrostatic induction. Then final point, charging by induction. Okay. Charging by induction. What we have discussed, conductors can be charged by induction. Okay. This is a charged body. Charge is Q. This is an uncharged body. This is bound induced charge minus Q. This is free induced charge plus Q. 1, 2, 3, 4. 1, 2, 3, 4. Okay. Now, this is earth. What we have discussed, if this is positive, then electrons flow from earth to neutralize it. Okay. Now, in the presence of inducing charge body, the induced charge body is earthed. This is now minus Q. This charge is vanished. Okay. Becomes 0. Now, in the presence of inducing charge body, we may disconnect the earthing. Because if we bring away this body, then the negative charge will also flow to earth. Okay. Now, the inducing charge body is taken away. Now, the whole negative charge will be distributed on the surface. Okay. Thus, previously this body was neutral. Now it becomes a negative charge. Accordingly, if you take it negative, this will be positively charged. This is charging by induction. Then another point, separation by induction. This is charging by induction. Charging by induction. Okay. Then separation by induction. Okay. Separation by induction. Let's consider this is inducing charge. You may take plus Q or minus Q. These are two conducting bodies in contact. When two conductors are brought in contact, then two bodies behave as a single body. Okay. Because charges flow in this body will also transfer to this body easily because this is conducting path. Okay. Now, opposite charge will develop at the near end and similar charge will develop at the far end. In the presence of inducing charge plus Q, now these two bodies are separated. Because if this body is taken out, again these two charges will combine. In the presence of inducing charge body, these two bodies are separated. So long as inducing charge body is kept here, opposite charges will bound to stay at the near end and this charge is. Now, the inducing charge body is taken out. Now, this negative charge will be distributed on this body and positive charge will be distributed on this body. This is separation by induction. Okay. Then, another point, students, before ending this lecture, which is surer test of electrification. Attraction or repulsion, which is sheer test of electrification. Okay. I will come to the point. Then some examples of frictional electrification. You go on thinking about this question. Okay. Amber rubbed against woolen cloth. There are some examples. Just I recalled now to discuss with you. When amber is rubbed with woolen cloth, then amber will become negative, woolen cloth will become positive. Then glass rod with silk cloth. Glass rod will become positive, silk will become negative. Then, as you have observed, plastic scale, if rubbed on dry hair, then plastic scale becomes negative, dry hair becomes positive, and it will stand up due to mutual repulsion. Okay. Then ebonite and fur means you may take cat's fur. Ebonite becomes negative, fur becomes positive. These are some examples. Then what is the answer? Which is your test of electrification? See, students, this is positively charged body, looking red, positively charged body. Okay. This is a negatively charged body. Okay. If both the bodies are oppositely charged, then there will be attraction between them. Okay. This is a positively charged body. This is neutral body. Then there will be attraction between charged and uncharged body by induction. So a charged body attracts both oppositely charged body as well as an uncharged body. So attraction may take place between two oppositely charged body and between a charged and uncharged body. But to have repulsion, both the charges must be similar. Means if both the bodies are similarly charged, positive or negative, then there will be repulsion. So repulsion is sure test of electrification. Okay. These were some elemental discussion in today's lecture. Before ending the lecture, again, I like to say thanks my young friends, thanks my students for your sincere support and your inspiration. Okay. Keep on